Good morning, all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I am going to discuss the 7-segment display interface using Arduino board. How we can display the numeric digits we will see with online simulation. So, in this, we are going to discuss the 7-segment display. The type of 7 segments we can have either common cathode type displays or common anode display. Next, we will discuss how to display the numbers using a 7-segment display. So, 7-segment displays are used in common household appliances like microwave ovens, washing machines, and air conditioners. They are simple and effective way to display a numerical information like a sensor reading, time, or quantities. In this session, we will discuss how to set up and program single digit and multi-digit 7-segment displays on an Arduino. 7-segment displays comes in wide varieties of sizes and colors. Some displays have single digit and other have 2 or 4 7-segment displays. Now first we will discuss about LED basics. So a single LED consists of 2 terminals. One is anode and the one is cathode. So for this LED, this we will consider as anode. The second terminal is cathode. The anode terminal is the positive terminal and the cathode is the negative terminal. So to power on this LED, connect the cathode to the ground and the anode to the power supply. Some DC power supply we can apply. The LED can be turned on or off by switching the power supply at anode or cathode. So all LEDs need a current limiting resistance placed in either the anode side or cathode side. It is to prevent the LED from burning out. So whenever excessive amount of voltage is passed to the LEDs, there is a chance of burning of the LED. To prevent this, we are going to be place a limiting resistance. If the applied voltage is very small, the resistance also can be neglected. So the resistance will determine how bright the LED will shine. So usually we will use a 1 kilo ohm resistance for practicing. So now we will see the 7-segment display will consist 7 LEDs, that is LED A, LED B, LED C, LED D, LED E, LED F and LED G. Apart from that, we can have a dot point. For that also you can program. So the 7-segment display consists of 7 LEDs called as segments A, B, C, D until G, arranged in the shape of 8. So most 7-segment displays have 8 segments. The 8th segment is nothing but the dot on the right hand side of the digit that serves as a decimal point. So each segment is named with the letters from A to G and DP for the decimal point. So each segment on the display can be controlled individually. There are 2 types of 7-segment displays. One is common cathode type, another one is common anode type. So now in the common cathode displays. So in common cathode display, all the cathodes of the LEDs are connected to the ground pin. This common pin is then connected to the ground rail of the circuit. The individual LED from A to G will be activated by passing the VCC to the corresponding pin. So whenever the VCC supply, here you can see the switch position. So whenever the switch is closed, if this switch is closed, the corresponding VCC will be passed to the LED. So whenever A is connected, see A will be displayed, B, C, D, E, F, G, then D. So if you are given the supply for the current element or the current segment is connected to VCC, then the corresponding segment is going to be in on state. Next one is common anode displays. In the common anode display, all the anode elements are of the LED are connected together and to the common pin. The common pin is then connected to the positive rail of the circuit. The individual LEDs can be activated by applying a low pulse or logic 0 signal to the corresponding pin. So now here you can see the cathode terminals are connected to a VCC. So whenever you are connected the switch to ground, so the corresponding LED is going to be on state. So now for displaying the numbers in the 7 segment display varying from 0 to 9. To display a number or pattern, activate the corresponding pins with the appropriate signal, depends upon whether it is common cathode type or common anode type. So if it is common cathode type, logic 0 we have to pass, that is nothing but active low signal. Or if it is common anode display, logic 1 or logic high we have to pass. So by this method, we can display the various digits from 0 to 9. So now for displaying the character, that is digit 0, if you observe the pattern, so A, B, C, D, E, F LEDs are going to be on. What about G is? G is going to be off state. When it comes to for displaying 1, here we can say the segment B and C will be on state and the remaining segments will be in off state. For displaying 2, A, B, D, E, G segments will be on and the C segment and F segment will be in off state. For displaying 3, A, B, C, D, G will be on. How about E and F means they are in off state. For displaying 4, B, C, F, G should be on. The LEDs A, D, E should be in off state. For displaying 5, LED segment A, C, D, F, G should be on. The LEDs B, E are to be in off state. For displaying 6, LED B segment should be on, off, and the remaining LED segment should be on, except LED segment, that is LED segment for 7 segment display for arm B should be an off, and the remaining should be in on state. For displaying 7, A, B, C should be on. The D, E, F, G segments will be in off state. For displaying 8, we had to make all the segments should be in on state. For displaying 9, except E segments, the remaining segments should be in on state. So the truth table for a common cathode display, common anode display signals will be, if you want to get, it is inverted. So for common cathode, for displaying 0, except 0, the remaining LEDs we have to connect to 1. So here 1 indicates it is plus voltage source, 0 indicates connecting to ground. So for preparing these slides, I have gone through these websites. Now we will see the online simulator, which is Wookwe, through which we will see how we can interface an Arduino board for connecting the 7 segment. Now this is the online simulator where we can program the various boards. So out of which we are going to work now on Arduino. And again in the Arduino, you can see multiple boards where Arduino Uno, Arduino Mega, Arduino Nano, 8085, Frangino. So now we are going to use Arduino Uno. We will select it. This is the environment IDE for programming the Arduino, where we can see on left hand side the programming part, whereas on right hand side we can have the Arduino Uno board, and we can connect a multiple devices for this. Now for importing the 7 segment display, here we can see the plus symbol. Here these are the various sensors and actuators are existing in this library. So we want to work on a 7 segment display. So I'm searching for a 7 segment display. So first we will try out with only a single 7 segment display. So I'm taking one 7 segment display. So now for this 7 segment display, you can see 1, 2, 3, 4, 5 pins in the downside, whereas on the top side we are having 5 pins. So total 10 pins are existing on this particular element. So which are the pins are corresponding to which segment? For knowing it, here just we will place the cursor on the particular pin. It is going to display here. So in the down side in the pin configuration, the leftmost is E segment. Next one is D segment. Next one is COM port, C port. This is for decimal point. On the top side, we are having the segments are G, F. The third one is COM port 2. Next one is node A. Next one is node. So now first we will see whether it is a common anode type or common cathode type. So for this, I am going to select the C segment. So this C segment, first I'll try out for connecting to VCC, which is a 5 volts. Then the COM port, we will connect this one to ground. Now we will run this simulation. So when we are connected the C node to the 5 volts and the COM port to ground, here also this COM port also will connect to ground. So when we run this, none of the LEDs are going to be on state. So that means the cathodes are not connected to ground. Now we will do the reverse process. Now we will connect the COM port to plus V, that is plus 5 volts. The C we are going to be connected to ground. This COM port also we will connect to 5 volts. Whenever we run this, we can see here the segment C is on. So when this segment C is going to on, so this segment C, whenever we are connected to ground, we are going to get the particular segment is going to be on state. So the COM port for this 7 segment display, we have to connect to 5 volts. To make it the corresponding 7 segment on, we have to connect it to 0. So now the same thing we will write by using the programming. So if you observe this programming, here we have two types of loops we are having. One is we are having a setup. The second one is loop. So whatever we write in the loop, it is going to be executed repeatedly. Whereas the setup, it is for mainly configuring the ports. Usually we use or to set the baud rates. We are going to use this setup. So this setup will work for only one time. At the time of execution, it will run for only one time. So now for this configuring, we will assign a port. First I am taking with respect to only C. So I will make use of the pin C. We will connect it to the pin number 3. So for that I am writing the statement is int C is equivalent to 3 semicolon. Now on the top here in the board on the top we can see DIO pins starting from 0 to 13. Total of 14 DIOs are there. So we can connect to any one of this. Now this segment C I will remove for connecting to ground, and this C I will try to connect. I will try to connect this one for the pin number 3. Now if you observe, the C segment is connected to the third pin of a DIO. So we have configured the C pin with the 3. In the setup, we have to write what is the mode for this particular pin. So for that we use the pin mode statement, whereas the pin mode we have to write the two arguments. What are the two arguments is? So we are taking the segment C that we have to connect either as a input port or output port. So we are going to write this one as a output port. So we will write the C as output port. Now here I am working with only one particular segment, that is C. Now here to pass logic 0 or logic 1, that we will consider as 0 as low, 1 as high in the loop. So in the loop, to pass the values, we are going to write the statements within the loop. So for passing the values, as it is a digital, we are going to use a digital write. So this digital write we have to give with two arguments. The first argument is for which segment or for which pin we want to write the value, and the next one is what is the value we want to write. So as we have seen in the last previous case, when the C terminal, that is segment C, we are connected to ground, the LED is going to be on state. So just I am working on only LED segment C to make it on. So for that we wrote a digital write as C comma low. So whenever we run this, see, this C segment is going to be on state. How I can make it off state? How I can make it off state means, for this digital write, instead of passing C as low, we will pass the value as high. So whenever you pass the value as high, and if you run this, you can say the segment is in off state. Now I want to toggle this segment C in both on state as well as in off state. So for that, what we can do is we will pass logic 0 as well as logic 1. So here I'll write one more statement where in the first statement I'll pass low. In the next statement I'll make it a C segment as high. So whenever we run this, if you observe the output, the segment C is continuously on. But here in the program, we wrote both logic 0 as well as logic 1. So let us assume if I wrote as a low first and later high, it is making on. Now we will see the reverse case. Now I'll remove the low first and I'll append this one as a second statement. Now whenever we are run this, so first we are passing high, then we are passing low. In this case also we can see the LED is continuously on, where the LED for high it is working, whether it is allowing high value or not means it is allowing, but it is a continuous running low high So the off state we are not able to examine here. So for examining this, so what we will do is we will write some delay. We will write some delay after passing a 0. We will pass some delay. So let us consider this delay value, we can pass anything. So whatever the value which you are passing as an argument in the delay, so it will give us a 500 milliseconds. Now we will give this one low for 500 milliseconds, then high. Again I'll pass delay because after off also I want to examine. So we will write the 500 for this 500 on state, 500 off state. Now when we run this, see, the C segment is going to be blink. So in the previous statement, when we are not having a delay, we are not able to see this on off state for the 7 segment display. Now we are able to make it connecting a C segment to port pin 3, and we are able to control the on and off state of the segment C of the 7 segment display. Like this, we can program any pin and we can make it on and off. The next we will try out for displaying a 0. So for displaying 0, we are going to write all the segment connections to any one of the DIOs. Total 14 DIOs are existing, out of which we require only 8 segments. One is for DP, the remaining 7 for the 7 segments of the 7 segment display. Now we will start with connecting A. So I'll search for A. This A pin I'll connect to the 0th pin of the board. Next B. B I will connect to 1. So A is connected to 0, B is connected to 1, C is connected to 3. So better we go for 1, 2, 3. So segment A we will connect to 1. Segment B we will connect to 2. Segment C is connected to C. Next segment D. This segment D we will connect for 4. Next segment E we will connect for 5. E is done. Next segment F we will connect for 6. Next segment G we will connect for 7. So DP is only left out. This we will connect to some 8. Now we will configure all the pins. So first int A we are connected to 1. Then int B we are connected to 2. C we are connected to 3. Next D we are connected to 4. E we are connected to 5. F we are connected to 6. Int G we are connected to 7. Next DP also we are connected, right? So we will write int DP is equivalent to 8. So this segment it is for a declaration of the pin for pin assignment. Now we will write all the pin modes. So as these are LEDs are nothing but output devices. So the mode we will write as only input. So if we are taking any sensor from which we want to read the data, so in that case we have to configure that one as a input. So now in this case we are taking the LED which is a output device. So we will configure that one as output. So first I will write copying all the statements, then I will change the corresponding values. So first one is we will make it A in output mode, B in output mode, C in output mode, then D in output mode, next E in output mode, F in output mode, G in output mode, next we have D. So now we have made for connecting all the 7 segment plus a decimal point as output mode. Next, the first we will write to display a 0. So here I'll put a comment. So for displaying 0. So as we know for digit 0, A, B, C, D, E, F, we have to make it on. Whereas segment G and DP, I will make it off state. So for that, in a single case, we are going to write all the 8 statements. So this first statement is for segment A, next one is for B, C, next one is for D, E, F, G, next one is D. So out of this, which one we want to make it on? We want to make it on for segment A, B, C, D, E, F. What about G? It has to off. And DP also we have to make it off. So for making off, we will write high value for it. So we made it high for segment G and segment H. So first I want to display only a 0. So for that, after writing all the values corresponding to on state, now after displaying this 0, I want to make it off state. So for off state means I'll make all the segments in high state. So I'll make A as high, B is also high, high. So why I'm writing high here it is after displaying 0. In the next case, all the LED should be off state. How we are able to see now. So now here I have made all the LEDs in high state so that LED will not be on. So this block it will makes the display for 0. After 500 milliseconds, we are making all the LEDs should be in off state. Again, we go for wait for 500 milliseconds. As it is a loop, it is a continuous execution. So first block, second block. Again, it will be go to the iteration. So now we will run this. So here you can see the 0 is displaying and off, displaying and off. 0 is displaying. After 500 milliseconds, it will be off state. Now let us consider I want to display for more amount of time. So what we can do is here we can increase the delay. So let us consider I'll wait for 200 milliseconds on as well as off state. 2000 milliseconds. You can observe from previous case to here how much time the digit is going to be displayed. Now I'll make a small changes in this where I'll display 0 for 2000 milliseconds, whereas I'll make off for 1000. Now you can see the toggling will be takes place at a different rate. So the display of 0 will be, you can see, for more amount of time, whereas all the LEDs in off state will be for less amount. Now we will change this program where we will want to display one after the other, like 0, 1, 2, 3, like this till 9. After 9, I want to display dot also. Then it will be go for displaying again 0 to 9 dot, 0 to 9 dot. So how we can handle that? So now here I want to display 1 after 500 milliseconds. For displaying 1, which one we have to make it on? B and C should be on. So for B and C will pass low and the remaining LEDs will make it high state. Now here we wrote two blocks in the loop. One is for displaying a 0. The second one is for displaying 1. And for after each and every digit, we have provided delay of 500 milliseconds. So now whenever we run this, the 7 segment display will 0, then 1, then 0, then 1. It is going to display like this. 0, 1, 0, 1, 0, 1 like this. Now we will extend this program for displaying 2 also. So for displaying 2, which are the LEDs we have to make it on? So for those LEDs will pass high for off state, 0 for on state. Next one is we want to display the digit 2. So for digit 2, this LED A should be in on state, LED B should be in on state, LED C should be in off state. Again, LED D should be in on state. Next, LED E should be in on state. Next, LED F should be in off state. LED G should be in on state. How about the DP? We want display DP now, so that I'll make it as off state only. Now when we run this, we have total 3 blocks. One is for displaying digit 0, followed by digit 1, followed by digit 2. So when we run this, 0, 1, 2, 0, 1, 2, like this, it will be displayed. So the variation, how much time we want to display, that we can alter by increasing the delay time. So this is for displaying 2. Now we will extend this program for displaying 3, 4, 5 till 9. Now I want to display 3. So for display 3, what are the digits or what are the segments we want to make it on? So that we have to write with 0. That is logic 0, which is nothing but low. A should be on, B should be on, C should be on, D should be on, E should be off state. So we will pass high. F also should be off state. G should be on state. DP should be high. Now we will see whether it is going to display the 3 or not. 1, 2, 3. 1, 2, 3. Now we will extend this program for displaying 4 also. So for displaying 4, So now I want to display the digit 4. So for displaying the digit 4, which are the LEDs we want to make it on? Accordingly, we have tried. So A, we have to make it off. B, on. C is also on. D should be off. Next, E should be off state. F should be on. G should be on. DP also off. 4. 0, 1, 2, 3, 4. Now we will extend for display 5 also. So now I want to display 5. For displaying 5, which are the LEDs we want to make it on and off? We have to see the pattern. So A should be on. So we will write A as low. B should be off. That will make it with high. C should be on. D should be on. Next, E should be off. F is on. G is also on. DP should be off. 1, 2, 3, 4, 5. Yes. Now we will extend the program for displaying 6 also. So for displaying 6. So for 6, except B, remaining LED should be on. So this will write as low, high. 6 should be off and remaining LEDs should be on. Yes. 2, 3, 4, 5, 6 display. Now we will extend this one for displaying 7. So for 7 display, A should be on, B should be on, C should be on, and the remaining LED should be off state. So A we will pass as low to make it on, B is on, C is also on, the remaining LEDs we have to make it off. Now we will run for checking display 7, 2, 4, 5, 6, 7. Yes. Now we will extend for displaying 8. So if you observe 8 pattern, for displaying 8, all the LED should be on state except TP. So for make it on, we'll pass low for each and every pin except TP. Now we will run this. 4, 5, 6, 7, 8, 0 until 8. It will be displayed continuously. Next, I want to display 9. So for displaying 9, so what is the difference between 8 and 9 in the display format is, for 8 all the LEDs will be in on state, whereas for displaying 9 we have to make it LED E, segment E should be in off state and the remaining LED should be on state. On 2, 3, 4, 5, 6, 7, 8, 9. Yes. Displaying from 0 to 9 is done. Now I want to handle decimal display also. Now we will write a program where I want to make it all the 7 segments of the digits should be off, only the decimal point should be off state. So for displaying DP. A should be in on off state. B is also off state. C is also off state. D is also off state. E is also in off state. F is also in off state. G is also in off state. Whereas the DP, I want to make it on. So we will pass this one to low. So this is for displaying a DP, and the remaining segments will be in off state. So when we run this program, you can see the display variation from 0 to 9 followed by dot 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 dot and continuous. Right. So this is how we can interface the 7 segment display with the Arduino board. So whenever you want to display any digit, whichever the pattern which you want to set, so those values we can get from these blocks. So here we have made each and every block of statement for displaying a particular digit, followed by last one is for DPs. If you observe here, for every time this transmit LED is going to be in on state. Whenever make it power on, this LED will be in on state. So this is how we can program the 7 segment display interfacing with Arduino board. The same kind of thing we can work out with respect to breadboard and physical Uno board also, where for limiting of the current you can add the resistance also. As here we are connected a DC source of 5 volts which is capable of driving the LEDs. I have not included, but still we can add a LED for each and every segment connected with one resistance, so that the limiting of also will be taken. So thank you. In this session, we have discussed how to interface a 7 segment display with the Arduino Uno board. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.